Namaskaram. This question is again from CSAT 2024, and this is actually a very easy problem. The actual question is a very good quality high level problem, but this problem become easy because of the option. Because if you look carefully, there is divisibility check by the numbers like 2 and 3. Okay, these are very small numbers, and especially when you're talking about 2, if all you have to see if a number is divisible by 2 or not is by checking if the number is even or not. Okay, what do you mean by even? If a number is divisible by 2, of course that is even. If a natural number or if an integer, if it is divisible by 2, then that number is even. So basically, if you take the numbers like if the numbers the natural numbers or integers ending with 0, 2, 4, 6, 8, yeah, that's it, 0, 2, 4, 6, 8, these numbers will be divisible by 2. Now, why this problem become easy? Let's directly solve the problem and you'll see. We'll write the number 222 raised to 333 plus 333 raised to 222. Now, if you look at this number, the first number, 222, that of course is an even number. 222 is an even number. So it's and it is being raised by 333. It basically means that 222 into 222 into keep on going, and they are multiplying this number for 333 times. Now, any even number, first of all, that even number, if it is getting multiplied by any other natural number or any other integer, that number will automatically become even. Okay, what I meant is that 2 into 3, this is also even, or 4 into 5, this will also be even, or 6 into which number, 11, 66, this will be even. If you multiply an even number with any other integer, the resultant will always be an even number. This is because this and all these numbers will be divisible by 2. Okay, this left side will be divisible by 2, right side also will be divisible by 2, because there is a factor of 2 over here, and this resultant will have a factor of 2. Now, if you look at this thing, 222 is getting multiplied by itself for several times. So even multiplied by even multiply, it will be even pro max. So if an even number is raised with a natural number, and be very careful, I am saying that an even number raised with a natural number. What do you mean by natural number? Numbers like 1, 2, 3, 4 and so on. If an even number is raised by a natural number, the resultant will always be an even number, because it is getting multiplied by itself. And why it is important, why this part natural number is important, is because if an even number is getting raised by, let's say, 0, you are going to get 1. Any number raised to 0 is going to be 1. A number raised to 0 will automatically become 1. Or if I am raising 2 raised to minus 1, see, 0 minus 1, they are not natural. This basically means 1 by 2, and that is 0.5. If a number is a fractional value, then it is not a natural number. It is not an integer. An integer cannot be categorized as even or odd. Only integers can be called as even or odd. That is why I am saying this rule only works when the power is a natural number. So any even number raised to any other natural number, you are going to get an even number. So the first half, here you are going to get an even number. Now if you will check the second part, 333 is of course not divisible by 2. That is an odd number. An odd number multiplied by another odd number will automatically be an odd. And it doesn't matter how many times you are getting multiplied. Like here they are multiplying it for 222 times. Even though it is getting multiplied for 222 times, it will still remain an odd. You can check with any example. 3 into 5, 15. Odd multiplied by odd is always an odd. Okay. Until and unless one single even comes, you will not get an even as a resultant of a multiple. So this right side you will be getting an odd number. Now an even is getting added to an odd number. Okay, even plus odd is always odd. Why is it so? You can check with any example. 2 plus 3. See, even plus odd gives you odd. Or 4 plus 11. Again 15. Even plus odd gives you odd. This basically happens because of a basic, the structure of even and odd. I'll explain that to you eventually. Anyway, even plus odd is an odd number. So, let me rephrase whatever I said. This part, even number raised to a natural number will give you even number. Similarly, odd number raised to a natural number will give you an odd number, and even plus odd will give you an odd. And it's a resultant of this thing. 222 raised to 333 plus 333 raised to 222. This will be an odd number. That basically means that the resultant will not be divisible by 2. Odd number is not divisible by 2. So there is only one option which suggests that the odd number, the following number is not divisible by 2. It's only getting this, only this option suggests that, therefore this answer can be answered just by a basic condition of even and odd. That is the reason why this problem becomes very easy. Now, going a little bit overboard, see, they have given the numbers like 3 and 37. We still have to check for if this number is divisible by 3 and 37. Not for the problem. The problem is done, okay? But for the learning, in the future, they might ask a different question. So, if let's try the divisibility check by 3. Again, let's take the number back. Our number is 222 raised to 333 plus 333 raised to 222. I am going to check if this number is divisible by 3. Instead of checking them together, I am going to check them separately. 222 raised to 333 divided by 3 plus 333 raised to 222 divided by 3. See, 222, the number 222 itself is divisible by 3. How can I say? Because the divisibility rule of 3 is that you simply add these digits, 2 plus 2 plus 2, and the resultant should be divisible by 3. See, the resultant is divisible by 3. Therefore, 222 is also divisible by 3. Therefore, if you check this thing, it will become 222 into 222 raised to 332. So, I'm separating this into two parts and dividing with 3. And this part is automatically divisible. If you divide 222 divided by 3, you are going to get 74. So, if I do the division, I am going to get 74 here. Similarly, here also 333 by itself is divisible by 3. Okay, you don't have to, it's very easy. You don't even have to add. If you add, it is going to be 9. That is 3 plus 3 plus 3 is going to be 9, and that's it. Anyway, here you are going to get doing the same process, 333 into 333 raised to 221 divided by 3. If you divide this part, you are going to get 111. So this entire number is divisible. The left side and the right side of the addition is divisible. If both the sides of the addition is divisible, the entire number will also be divisible. Okay, so that's how you check the divisibility by 3. Now we can also check the divisibility by 37. So the divisibility by 37 is, again, I'll take the numbers, 222 raised to 333 plus 333 raised to 222. Divisibility by 37. For checking the divisibility by 37, I'm going to take the help of, I don't have to take remainder theorem. I can still use the same method which I used above. For example, 222 into 222 raised to 332 plus 333 raised to 1. So I'm basically separating that 1 into 333 raised to 221 divided by 37 divided by 37. And if you check this individual parts, 222 divided by 37 will give you 6. This part is divisible. Here it is 6 you are going to get. Similarly, 333 divided by 37, you are going to get 9. So each part are individually divisible, therefore the entire number will also be divisible. Even if these individual parts are not divisible, there are some other ways with which we can check the divisibility of the sum. Okay, for that level, we'll have to use remainder theorem. And maybe eventually, if I get some good question, I'll show you that. Or when I teach you remainder theorem, I'll be teaching you that. As of now, this problem is a very easy problem. You can do it simply by using even and odd. We can, in a single look, you can say that this number is not even. It is going to be odd. Therefore, it won't be divisible by 2. So answer is B. So that's it. Thank you.